So far on defenses, we've only looked at the web app. So how can we keep our errors from disclosing internal implementation details? How can we reject invalid, untrusted user data? And then how can we parameterize using inline SQL parameters, stored procedures, or ORMs? I want to take a look now at the database layer itself, and particularly at the principle of least privilege. And this is a really fundamental concept, not just with database permissions, but really with any part of application design. And it's all about identifying the bare minimum permissions that each component of the system actually needs to do its job. And inevitably, what we have at the moment, and something that I've mentioned many times throughout this course, is that the web application is connecting using an identity that's got far more access rights than what it actually needs. We particularly saw that when it came to access rights that allowed the web app to do things like create SQL logins. That should never be able to happen. There's absolutely no reason why an anonymous user browsing around a public website should actually be talking to the database with enough rights to escalate their own privileges by creating their own login. That's just a ridiculous situation to be in. So let's jump over to SQL Server Management Studio. And in my Hack Yourself First database, we can see that I have a user called Hack Yourself First Restricted. Now, this is exactly the same as the account that's used on the live public website. Let's have a look at the permissions that this guy has. If we go into Properties, and we have a look at the memberships of this user, it's a member of both Data Reader and Data Writer. And that means that by default, it can read and write from any single table in the database. Now that's excessive. We don't need to be able to do that everywhere. So as an example of the principle of least privilege, let's remove both Data Reader and Data Writer. I'll go to my securables. I'll search for objects in the database, and I'm going to search for all objects of type, and the type I'm going to choose is just tables. So let's have a look at all the tables. Now, just as an example, what I'll do is we'll just go to the supercar table. And in that supercar table, I am going to allow it to select. Now, what this means is, as of this point in time, the only thing that the web app can do with this database is select rows out of one table. We can go even further. We could go all the way down to column permissions. And then, for example, we could say, I only allow it to select the number of cylinders, the description, the engine capacity, and so on and so forth. Now, I'm not too worried about that for this particular table because it's meant to be read by everyone. But that could be useful for other entities in the database where you may not want everyone reading every column. So I'm going to cancel that, but I am going to say OK to this one, and then I'm going to jump back over to the web app, and I'm going to try an attack here. And this attack is going to be a union-based injection to get all the passwords out of that user profile table. So remember, that one looks just like this. And let's run that. Now, because I'm still allowing these internal errors to bubble up into the web app so that you can see what's going on, we can see the exception here. And we can see that we no longer have select permission on the user profile table. So besides all those other mitigations we've already looked at in this module, this principle of least privilege puts an immediate stop to being able to pull data from that table. Now, of course, you do actually need users to be able to query the user profile table because that's how they log in. But the mitigations to this would include things like using a stored procedure that has execute permissions, because when you do that, you don't need Data Reader on the whole table. You now have one little programmatic structure, the procedure, and you give the access rights to that. So the stored procedure could compare a password with the one stored in the database and then return whether authentication has been successful or not, but a user couldn't use an injection attack just to select directly out of the table. Now that is a very fine-grained permissions implementation, but I want to give that as an example of how we can structure the way the application is designed such that we greatly limit the access rights the user has to the underlying database. Now with that said, let me jump over and point out a few key areas to think about when you're looking at the principle of least privilege. There are a few things that you can think about here. And the first one is whitelists again. So we spoke about whitelists a little bit earlier on when it comes to validating untrusted data from the user. You can also apply whitelists to the permissions on the database, insofar as it's a matter of saying, hey, what should people actually be allowed to access? And when we talk about that allowable access, we can make it very granular, so we can go all the way down to the column level. Database servers like SQL Server do have a huge amount of configurability in this area. I mentioned stored procedures just before as well. So these are a good way of restricting access rights. If you can remove those reader and writer rights, particularly from sensitive tables, and use stored procedures instead, that is a much more secure position to be in. What you do have to be a little bit conscious of though, is that that is at odds to some of the modern movements around using tools like ORMs, because ORMs generate their own SQL, and that generated SQL needs access to select out of these tables. So it'd be very hard to use an ORM to directly query the underlying table and then not have read access to something like the user profile table. But again, this is all about defense in depth. So it's a question of defining what are the right defenses to apply in the right places. You can still have read access to the user profile table if you get all of these other layers of defense correct. And indeed, if you are using an ORM that requires that sort of access rights, at least you know it automatically parameterizes. So the whole thing is a bit of a trade-off. Now, speaking of trade-offs, the last point I'll make here is around using multiple SQL logins. So in the example I just showed you where we removed read access to the user profile table, there may be times where you legitimately require read access to that table, but only via admins. So one way of applying this principle of least privilege in a more granular sort of fashion is to have multiple SQL accounts used for different roles in the system. If you're part of the general public, you can't select from this particular table or insert or update into most tables. But if you come in as an admin, then you connect using a different account, and that account does have the rights you need. So this is really about sandboxing the permissions so that a risk in one part of the app doesn't necessarily bring other parts of the app undone. This is all a really, really key concept within SQL injection. So do look at how you can apply this principle in conjunction with the other defenses we've looked at in this module.